In this video, we will talk about integrals of exponential functions with bases other than e. First, we will derive the formula, and then we will look at some examples. So recall that if we have function like f of x equals e to x, so this is an exponential function with base e, then we know that the derivative of this function is e to x itself. And from that, we can quickly derive the formula for integral. So integral, the antiderivative of e to x will be e to x plus constant. Now in this video, we are mostly concerned about the integral of function of this form a to x, where a is any number. Where a is a constant. First, let's derive the formula. And to derive the formula for integral of y equals a to x, first we look at the derivative of a to x. From calculus 1, we know that this derivative equals a to x natural log of a. And next we can divide both sides by natural log of a. That will give us 1 over natural log of a. Derivative of a to x equals a to x. Next, I can move this natural log of a inside the derivative. And we get derivative of a to x over natural log of a equals a to x. So from here, we can say that the integral of a to x with respect to x is simply a to x over natural log of a plus constant. This is the formula for the integral of a to x, where a is any constant. Next, we'll look at some examples. So first, we are looking at integral of 2 to x. Integral of 2 to x dx. So we can simply apply the formula for integral of a to x, which I have put down over here. So integral of a to x is a to x over natural log of a. Our a in this case is 2. So it will look like 2 to x over natural log of 2 plus constant. And that's it. Let's look at the second one. Here we have integral of 3 to cosine x, sine x dx. Now this looks like a combination of a few functions here. Here we have first part is a composition of exponential function with base 3 and cosine x. This part is a composition, and the sine x is by itself. So whenever we have a composition, one possibility is to try to use integration by substitution. So we start by letting u to be the inside part of the composition. So here composition is 3 to cosine x, and the inside part is cosine x. So we let u to be cosine x and see if that will work out. Now we want to express the whole integral in terms of u. So we want to find dx in terms of du. Du over dx is the derivative of cosine x, which is sine x. Then this implies that dx equals du over negative sine x. Now we are ready to write integral in terms of u. We have 3 to u. I'm going to keep sine x as it is for now. And dx is du over negative sine x from over here. So this becomes 3 to u as it is over here, and it looks like sine x gets cancelled out very nicely. So we are left with a negative sign over here. I can bring that all the way to the front, negative, and then we are left with du. So we have negative integral of 3 to u with respect to u. Now we can simply apply this formula with a equals 3. So our base a is 3 in this case. Then we get 3 to u over natural log of 3 plus constant. And finally, we can replace the expression for u back. So we get negative 3 to cosine x over natural log of 3 plus constant. So this is the antiderivative for the second one, for the second problem. Let's look at the next one now. Third one, here we have the same function, but we have limits. So this is a definite integral. We have 3 cosine x sine x dx. So we again start by letting u to be cosine x. So we want to express dx in terms of du. So to express dx in terms of du, we can find the derivative of du, which comes out to be negative sine x. Then this implies dx equals du over negative sine x. And then we also want to change the limits because these given limits of integration are for x. We want the limits for u. So when x is 0, we have u equals cosine of 0, which is simply 1. And when x equals pi, then we have u equals cosine of pi, which is simply negative 1. So now we are ready to write the integral. So this becomes integral from negative 1, actually 1, when x is 0, u is 1. So from 1 to negative 1 of 3 to u, we are letting cosine x to be u. And I'm going to leave sine x as it is for now. And we found that dx is du over negative sine x. Again, sine x gets cancelled out. Then we are left with negative integral from 1 to negative 1 of 3 to u du. Okay, now we are ready to do the integral, and we can apply this formula with a equals 3. So that will give us negative in the front as it is, and integral of 3 to u will be 3 to u divided by natural log of 3, which we evaluate from 1 to negative 1. So I'm going to write here next. So we have negative 3, and when u is negative 1, we get 3 to negative 1 over natural log of 3, minus when u is 1, we get 3 to 1 over natural log of 3. So next I can factor out 1 over natural log of 3 to get negative 1 over natural log of 3 in the front. And here inside the parentheses, we have 1/3 minus 3. So this will give us negative 1 over natural log of 3 in the front. And 1/3 minus 3 is, because 3 is 9 by 3, negative 8 by 3 is what we get here. So this becomes 8 over 3 natural log of 3. So this is the value of this definite integral. Let's look at the next example now. The fourth one on the board, we have integral of 3 to x plus x cubed dx. So these two, although they look very similar, 3 to x plus 3 to x and x cubed, they are completely different functions. So I can write this as sum of two integrals, integral of 3 to x plus integral of x cubed. 3 to x, looking at the formulas we have available, it looks like a to x. So we will be applying this formula with a equals 3. Then we get 3 to x divided by natural log of 3 plus, for the second part, this one looks like x, this one x cubed looks like x to n with n equals 3. So we will apply that formula, x to 3 plus 1 over 3 plus 1 plus constant. So I'm going to go one step further, simplifying the second part. We have 3 to x over natural log of 3 plus x to 4 over 4 plus constant. So this is the antiderivative of 3 to x plus x cubed.